folks, Eric Woldridge here of the Additive Guru channel. Today we're going to walk through a design of something fairly simple. This actually came to us as a request to design a belt hook for a bullwhip. We've got a farmer rancher that utilizes bullwhips in terms of their cattle working, and has asked us to design something to be 3D printed to make a quick loop onto their belt. So what we're looking at is something fairly simple, something that will be pretty easy to design. Maybe have like a little latch hook here and something that will come around and snap fit in, and then a little bit thicker toward the bottom, so that your belt, of course this is in section view, so that your belt will loop through this, and then the whip itself in its bundles, not a very good bundle I admit, will fit in there, and then this piece will latch in some form or fashion. And we'll do a very simple version. The final one may be a little bit more complex, but at least show you the process. Just to give you a feel for what we're going for, you know, and I think he said this type was specifically the paracord version. You know, this is typically how they're looped together, and the belt loop that we're going to be making will allow it to be wrapped up and hooked back in and on the side of the belt when not in use. There's a better version. So, right, actually, look at that. There you go. So what we're trying to simulate is the ability to, try that one. What we're trying to do is simulate the ability of something to hook right here so that it can attach to the side of the belt. All right, so let's take a look on the fusion here. Just for quick dimensioning, belt itself will generally, the opening for the belt will probably be about 5 millimeters by 50, generally that size. Maybe we'll go 60 just to be in case someone's got a little bit extra large belt, but we need opening of that size, and the relative bundled size of the whips as they are, you know, the strands are lapped across each other, we're going to assume is a diameter of about 30, representing it by a circle that will represent the bunch. Granted, it's going to be a little bit more, typically they'll be more elliptical in shape, or maybe just a little bit of more of a teardrop arrangement, but it gives us something to work with. Alright, so let's give it a shot. First thing I'm going to do, and we'll assume that it's going to be 3D printed out of TPU. So the first thing I'm going to do is actually design the opening slot for the belt to pass through, and I'm using 60 by 50 rectangle there, and I'm actually not going to use this. I'm just going to design from it. So I'm going to go ahead and set that, all of that, to a construction line right here. And if you don't see your construction lines, that's the little fly out window here in Fusion. And so from that point in time on, I'm going to do that, and then maybe go ahead and design in the 30 diameter representation of the, if I can get to hold, representation of, come on, there we go. I'm having a hard time getting this thing to obey. There we go, sorry. So that's roughly what we're shooting for, with enough wall thickness here to handle that, and I will design around all this, maybe making some changes as we go. Now, one of the things that I like to do is I really like to use splines more so than anything else in the creation of our work, because it gives us more ability to control things and adjust where stresses may be occurring. And so I may do that to this point and just stop. It doesn't need to be a construction line. There we go. Another thing that I'm going to do is I'm not going to use these corners of the rectangle as my opening slot, because whenever you have something like this, construction line still on, whenever you have sharp corners in just about any type of design that's under stress, sharp corners are bad, and they make stress concentrate itself in those corners. So we don't really want that, so I'm going to kind of do a spline here to round around the representation of my opening. This will give me the ability to come in and kind of really smooth out those corners and do something that I can adjust with thickness and avoid sharp corners as much as possible in my design. And I might even decide to tighten it up a little bit around the walls to get a little friction against the belt so it doesn't want to slide along. Okay, so we've got that, and we know roughly how much thickness we need there. I can thin this up a little bit. And sometimes it never hurts to do this, to draw a circle in your space and set to maybe a diameter of 6 to give yourself a sense of size while you're creating. So that way when I look at this circle, I know that this is roughly in the 4 to 5, 6 zone, and I can choose to pull it out a little bit more to give me a little more wall strength. And I can always drag it in and look at it and then pull it back out to see if I'm getting a little bit too tight on certain corners. And I often suggest that designers get a feel for using the 6 diameter circle so that you can not oversize or undersize. Don't always make it all about dimensions. Make it about the size that you're after. Okay. And so I'm going to go ahead and, if you want to, pause the video now and kind of get to where I am at this point, and we can continue on. Okay, so let's get going with the rest of it. My objective now is to figure out how I'm going to create my, sort of a snap fit feature. I want it to hook this way and to come down, of course, and I want this piece to come up and hook inside it. And that the pressure of the whip inside the harness here will put pressure against this point. That way I can slide it out when using it, that sort of thing. So that's our overall goal here. And we're going to assume that this whole thing is going to be printed in one shot, one direction, where we would be looking down on it from the perspective of the build plate. So it's all coming at us, and that will keep us from having to worry about overhangs and support material. So I'll probably want to design on down that way and maybe create a shape kind of like that. I might want to have some straight lines here because that may work really well with a good tight snap fit, or kind of a sliding connection point there. Not truly a snap fit, but you get the idea. So what if I go ahead and come out and sort of wrap this around this way, and just stop. And then I can go back and turn my construction lines off for sure. And then I can turn around and come in through here. Maybe get to about right there, stop that. Maybe continue on from this point and just kind of wrap it. It doesn't have to be perfectly on that circle. Again, we want the ability to have some maneuvering with our work. And as you can see, I'm going to have to do some maneuvering here to pull that back in place. Maybe pull this out a little bit higher. This may be something that I change over time, but at least allows me to draw a line from here to here. Pull this up a little bit. Again, kind of glancing over at my 6 diameter circle so that I have a feel of size in terms of getting too small or too large. And I may choose to go ahead and maybe just make the rest of it a regular line. Come in real close. And maybe I'll just connect there. And then spline the rest of the way around. Nice. Smooth fit there. And I can even pull it up and get it as a tighter fit at this point. Again, hoping that the pressure of the whip itself will create the good tight fit that I need here. And if it doesn't, that's not a problem, because I can always tie this in a little bit tighter there and a little bit there. You'll notice that I'm doing what I said don't do, and that's making a sharp point there, so I'll probably need to fix that with a fillet. And maybe a little bit more there. And this, of course, is just only going to be one possible way of doing this. And maybe I want to tighten up this just a bit too. We'll see. Now I know that this is going to be a tight stress point because of the way it's going to be bent, so I'll kind of pull that in, maybe pull this out a little bit, and maybe just give it a little bit more strength, more material in this zone. Pull this back some, maybe flare that down a little bit more. And again, we'll probably use TPU to make this. So, kind of shaped it a little bit. Got my 6-unit circle to kind of zoom around through here and see how we're doing on thickness. Doing pretty good. Don't really necessarily need a lot of thickness along that wall. And I can probably pull this in a little bit tighter. And that's the best part about these sketches, is you can always turn around and come back and adjust them as you do a quick test to see how it's going to fit. And who's to say you might not be able to do this in something other than TPU? You might be able to use this in NinjaFlex, or maybe even PLA, maybe ABS. You might be able to get just enough movement out of what you need to make this happen. Now, again, I'm going to avoid my sharp corners as much as possible by turning around and using a fillet, clicking on this point, and that's a little bit too large. And then I'll click on that one, and then I'll click on, if I can get in close, click on this one, and maybe this one too. See how it does that one. Doesn't really like that one that much, but it'll work. And then maybe this one. And so I've kept those from being too sharp. Definitely want to avoid sharpnesses whenever we can. And I can still pull this in a little bit more to make a tighter, kind of overlapping fit. Now we do want to be careful, of course, in production, in the fact that, whoa, don't want to do that, apparently. We don't want this thing to actually bond to the other surface at the same time when it's actually in production. So I may want to pull it back out. I do want a tight fit, but not so tight that it actually touches the other walls when production and then makes it hard to get out. So a little bit there to protect that sharp corner. And this will sort of put a squeeze on the overall top part of the whip structure, which might be good for us. I may be a little overzealous right there, so we'll take that out and maybe pull in just a bit more right here. Always kind of back and forth. And see this? I don't want that. I don't want those pockets to kind of create that way. You can click on them and actually just adjust the curvature so that it's not too sharp, or about right there. So you don't get like a tiny little pocket. Okay. So at this point in time, I've got a potential design in mind, concept to work with. I hit finish sketch, and I'm going to extrude my object. Click on extrude, and let's just say it's always good to have a ruler on your desk to give you a sense of size. I can imagine this thing being about 25. We can start there at 25 units in thickness, and there we go. Now, if you want to kind of like smooth it out even more, you could turn around and use a quick fillet and try a chain selection depending on the number of points you have, and see if it will let you do like a quick little radius. Yes, it will. Kind of round those tops off. That's always nice. And then I can turn around and add on another one down below and say that one, and that one, and that one, and of course the outside there. Also set it to 1. Smoothing that out, and then one more here by clicking on this one, radius 1. And so now no real sharp corners. It could slide right down the belt, maybe a little bit too thin here, we'll see. But a good chunk of the weight is going to rest probably at that point, and then we will see how this would hold up in terms of bending. But there's the creation, and what we would do is probably set it up for printing on a typical FDM system, or maybe SLA if you want to use a little bit higher precision with some flexible material to see how it would work out. Alright, so give it a shot yourself. You can kind of finish it up there. You can print it off yourself, see how it works. Go out and buy you a whip if you want to, see how it works with your design, and can be useful for a bunch of other different designs. Now in theory, one will be able to kind of pry this edge. I may consider like trying to make it thinner to where it slides apart, or working with something, maybe creating a little edge right here to pry this out, depending on how it works together. So that's part of the process, is figuring out how to manipulate it when it's actually in there under pressure, and how you're going to get these locking points to unlock, so to speak. Alright, so good little project, and hope you enjoy, and check out some of our other videos and tutorials on fusion, generative design, lattice structures, and whatnot, and our social media accounts. Thanks for watching, and happy designing, happy printing. We'll see you.